Welcome back. Good evening, everyone. Tonight we're going to be talking with Joe DeLeo, who is visiting us from WeatherBELL Incorporated, one of the country's lead private forecasting services. He's going to be talking to us about Hurricane Sandy and some of its implications, along with the meteorology behind it. Welcome, Joe. Thanks for joining us.
Thank you, Anthony. Indeed, I will be talking about Sandy. It's the storm of the hurricane season, certainly this year. My presentation is called Eye of the Storm. Now, Sandy didn't have much of an eye, so I used Hurricane Isabel's eye. As you can see in this picture. Move to the next slide. We can see uh, the Sandy as it moved away from the Bahamas and up toward the northeast. It was in training dry air in the southeast part of the storm at that time, so that's why you don't see a well-formed circulation. But we were not concerned that the system would fall apart. Indeed, it had a lot of energy to the west as it was entering the system, a very cold trough to the west, and lots of moisture to the east that would entrain into the system. As you can see on the next slide, that moisture wrapping around now uh, the center of Sandy as it moved to the north. Now, Sandy was in 2012, following on the heels of Irene in 2011. If you go to the next slide, that uh, is 2 years in a row, and some made a big deal out of being hit 2 years in a row. But in the 50s to 1960s, there was 7 storms that hit the northeast coast. And this time it was overdue because the Atlantic and Pacific Ocean temperatures are in modes like the 1950s that favor East Coast hits, including the Northeast. On the next slide, that Atlantic multi-decadal oscillation, as you move to the next one, when it is in its warm mode, you can see this horseshoe of warm ocean water. The oranges and reds are warmth, and it includes the tropics and the eastern Atlantic. No surprise that that would generate more tropical activity than the cold AMO modes, the decades, and then like in the next slide, that show the opposite pattern occurs. The water turns cold in the tropics and in the eastern Atlantic, and activity diminishes. I show the AMO on the next slide, and you can see how nicely it varies on a 65 to 70-year time frame and stays pretty consistently in its warm or cold mode. The last time we were warm, from the late 20s to 1961, we had quite a bit of activity. Uh, it became cold then and stayed that way till 1994, and the Atlantic activity diminished. After 94, it warmed again and it picked up. And the next slide we can see, this is Bill Gray's summary of the 17 years when it was cold. And you can see with colder water, less major hurricanes, only 27 from 78 to 94. Whereas when it turned warm in 95, in the 17 years that followed, we had 65 major hurricanes feeding off the warmer water. On the next slide, you can see also when Atlantic is warm, there's more storms, there's more landfalling storms than in the cold mode. On the following slide, I summarize the storms that affected the Northeast, and you can see when it's warm and it's hatched on the top in rows. We had a whole series of storms from the 30s to 1960, 38, Hurricane 44, and Hazel, Connie, and Diane in the 50s, and then Donna in 1960. And then a quiet period when the ocean turned cold. It blipped warm, and we had Hugo and Bob, and then Bertha, Fran, Floyd, and Isabel in the 2003 time frame, and then 2010, 11, and 12, we've had Irene and Sandy. So when the AMO is warm, we tend to get more storms. Now, on the Pacific side, it goes through a similar kind of oscillation that does affect the chances of a landfall in the Northeast. And as you see here, the big blue whale in the warm PDO, Pacific Decadal Oscillation, and this lasts a couple of decades. Warm water tends to be located near North America and in the tropics, where it favors El Ninos. El Ninos increase the shear in the Atlantic, which diminishes the number of storms and the chances of landfall. On the next slide, the opposite mode, when it flips into its cold mode, where it is now, we have warm water in the northwestern Pacific and cold water along the west coast of North America and in the tropics, favoring La Ninas. And La Ninas are much more favorable for Atlantic activity. They don't increase the shear in the Atlantic side of the Central America. If you look at the next slide, we have that PDO oscillation. Like the AMO, it goes into and stays in a particular mode most of the time for decades at a time. And it was cold from 44 to 76, and then warm until 98, and then mainly cold afterwards. On the next slide, you see the impact of the PDO on the number of storms that affect New York and New England. When it's cold, those decades had more storms that had impact, and when it was warm, less storms with more El Ninos. But they work in concert, the Atlantic and Pacific, as the next slide shows. You can see how they're not totally in sync. Right now, the Atlantic is warm and the Pacific is cold. The last time this happened was in the 40s to early 60s, and that was a very active period. So there's no surprise that we're indeed in an active Atlantic East Coast regime. Next slide, you see the years in which the Atlantic was warm, the Pacific was cold, and we had La Nina. We had all of those. We had 17 landfalling storms in 12 years, 13 major hurricanes, and 12 affected the Northeast, including Isabel in 2003 and Irene last year, Sandy this year. The next slide shows Isabel in 2003, beautiful looking display. And then Irene in 2011 on the next slide. And then this year, not as pretty a picture, but a monstrous impact storm, Sandy, as it approached New Jersey coast. The next slide shows the actual surface map as it approached the coast and of New Jersey, and that land that converges there from Long Island and New Jersey. The water is piled up there as that storm comes in. Now that storm was quite intense. It had a very cold high to the west and a big high to the east. And Joe Bastardi and WeatherBELL was way out ahead of the pack in seeing this as a threatening storm for New Jersey and New York City. This is a 5-day forecast from Joe Bastardi. In the next slide, as you can see, the next slide, the storm coming into New Jersey and his 5-day forecast. Because it was running into cold air, the next slide shows the National Weather Service and the Hurricane Center decided not to issue hurricane warnings, but to instead issue high wind warnings and hurricane wind warnings over ocean areas. And this may have affected the decision making of some people who maybe decided to stay because they've been in winter storms before, and how bad could it be. But on the next slide, you can see the storm maintained a tropical core even as it came ashore. This is the 500 millibar standard deviation of temperature. And you can see it's 4 or 5 standard deviations positive. It actually was above 0 degrees Celsius. It only happens in tropical systems. when it came ashore. So it still maintained that warm character. You can see that cold air to the south that wrapped into the system and converted it to a cold core system very shortly after landfall. But it was warm core and should have been called a hurricane on landfall. You can see on the next slide the wind wave models had winds whipping up 20 to 30 plus feet of waves and swell action and turning southeast as the storm came ashore at the absolute worst time, at the time of high tide on the evening. On the next slide, we can see the forecast of the models for high tide predicting for the battery, southern Manhattan, a water level of 11 feet. You can see on the next slide the slosh models suggested for that kind of a storm surge, major flooding in southern parts of Brooklyn and Queens and Manhattan and Staten Island, and indeed that occurred, very much like a Cat 2 storm. The following slide shows that the actual flooding area, shown in blue here, fit the Cat 2, not only for Long Island, New York, Staten Island, but as you go to the next slide, also for much of the New Jersey low barrier islands and low-lying areas. The next few slides show the pictures of the results. This is Hoboken, New Jersey first. The second one is downtown Manhattan. The third one is water flooding into the Brooklyn Battery Tunnel. The following slide is the water pounding the Connecticut shoreline. Even Long Island Sound was hit hard. Now, has New York ever been hit by a hurricane? Well, yes, number of times in the past. Most of the time it's further east on Long Island and into New England. But in 1821, it was a Category 3 hurricane that came from the south into New York City and held the record for the storm surge at 11.2 at the Battery. But that's because it came at low tide. Sandy was a Cat 1 hurricane, but it set a new record for storm surge, 13.88 feet, because it came in at high tide and with a full moon. And compared to 1821, sea levels are a foot higher because that was the mini ice age. Excuse me. If the 1821 hurricane came at high tide, the surge would have been 6 to 7 feet higher, maybe 17 to 19 feet. So it could have been worse. Sandy affected 24 states and 2 provinces. The original guess was $20 billion in losses, but Governor Christie says $29 billion for his state alone, over $50 billion if you include lost business. Over 200 deaths in the U.S. and in Haiti, Cuba, and the Bahamas. 8.5 million people were without power, and still people without power in the dark and in the cold a month later. And on the next 3 slides, we see the day the lights went out was from the NASA satellites. There the lights were on, and then after the storm, much of the area was in the dark. Now, the 2 other points I wanted to make about Sandy is this just transferred into an extratropical cold system when it came ashore, and indeed it produced 36 inches of snow in West Virginia. Most all hurricanes go through the transition to extratropical cold lows, but usually it's well out at sea over cold water, like on the next slide you can see Hurricane Florence did in the North Atlantic back in 2006. What was unusual on the next slide was the track west and the capture by cold winter-like trough. But that didn't surprise us because that was the pattern we had for the winter. As you can see on this slide, we expect that the winter will be characterized by these cutoff lows and upper levels in the off the west coast and in the Atlantic, south of a blocking high east of Canada. And if you go to the next slide, that's exactly what happened with that blocking high east of Canada forced a low to cut off the cold air to pool underneath it. Sandy had nowhere to go, couldn't go into that block. It had to turn west to make landfall. Ironically, on the next slide, you can see that 2 weeks later, a similar kind of thing happened. We didn't have a tropical storm to absorb, but a cutoff low was forced underneath a blocking high over eastern Canada, and this resulted in a snowstorm, a very early one for the Northeast. The second point, or the last point I want to make, is the water. It was claimed that the water was unusually warm and contributed to uh, the strength of Sandy, and we haven't seen water temperatures like this before. It really hasn't warmed over the last 70 years. Yes, it was above normal, but not extreme. And Bob Tisdale did this for What's Up With That. You see the coordinates, the box he defined for ocean temperatures. The storm passed through that box. And then finally on the next slide, he showed that when you do the temperature, there's no trend. In fact, it's slightly, insignificantly down the trend. Now, it is a little warmer than normal, comparable to the 50s and 60s when we had all those earlier problems. But that was not the driving force that made this a devastating high impact storm. So in summary, despite the fact we just had a Cat 1 storm, it was devastating because of this large size, high storm surge, the fact that it was absorbed by a large winter trough, which led the storm unusual westerly. The surge was augmented by high tide and full moon, and the fact that the sea levels are a foot higher than they were 200 years ago. Now, these captures and transitions of hurricanes to large extratropical lows are common but rare in this location. And as bad as it was, it's not the worst case scenario that Joe Bastardi and I worry about. A Cat 3 storm, racing northeast and hitting New York City from the southeast and accelerating. Uh, Given the natural state of the two oceans, this storm was overdue. Given the continued warm Atlantic and cold Pacific, we may see more before it's all said and done.
Joe, thanks for that presentation. Question for you. Do you see this thing as being, in any way, shape, or form, connected to climate change? A lot of people are making that connection. What do you think?
If you include natural climate change, I would say yes. We do, as I said, go through the cyclical change in the Atlantic and the Pacific, and like the 50s and 60s, we're back in that same mode we were then. Not surprised that we are seeing storms. As I said, I'm surprised we haven't seen more, because we saw 7 in the 50s, from 54 to 1960. We've seen 2 so far in this particular warm cycle. I don't see how CO2 plays a role in the activity we've seen with Sandy and Irene in the last 2 years.
Okay, thanks, Joe. All right, that concludes our presentation from meteorologist Joe DiLeo, a certified consulting meteorologist licensed by the American Meteorological Society, who works for WeatherBELL Incorporated, one of the nation's largest private forecasters, available at weatherbell.com. We'll resume in just a few minutes.